Hello everyone and welcome to lesson 27 of the Save My STEM Physics channel. We're still in the mechanics section of the course, so today we are going to be covering terminal speed. Now, you may know already that ignoring air resistance, we can say that the acceleration of any object is 9.81, or if we're following typical sign convention, because it's going downwards, negative 9.81 meters per second squared, right? And we can derive that by Newton's second law. If F equals ma and there's no air resistance, then the only force acting on an object is its weight. So weight equals the resultant force. So we can say mg equals ma, and therefore g equals a by dividing by m on both sides, right? It's just as simple as that. But air resistance exists. We know that. It causes issues for us. And this is the only real part of the mechanics section of the course where they ask us to think about air resistance. So, terminal speed is, say you have, I'm just going to draw a free body diagram here. Say this is a skydiver, and he obviously has his weight acting downwards, mg, so he's going to be accelerating downwards, provided that the resistive force, air resistance, is less than mg. So he's going to accelerate down all the way till he reaches the ground, right? And so if we just take, there's no air resistance, so W weight is the resultant force, then we're just going to have a straight line graph starting from 0, because he's moving downwards with 0 speed, all the way to negative, well, all the way to whatever his speed will be when he hits the ground, which we can figure out by Suvat, and the gradient is going to be negative 9.81, given that this is a velocity time graph, right? Because the derivative of velocity, or the gradient of velocity, should be minus 9.81, as derived up here, right? But one thing that we do know, as I've stated before, is resistive forces exist. So what do we do about that? Well, something that you should know about drag, or about air resistance, is that the resistive force is directly proportional to the velocity that you are traveling at. So that means that this resistive force is going to start off quite small when he's not moving downwards. Well, it's going to be 0 when he's not actually moving. And then it's going to increase as he gets moving faster due to this acceleration due to gravity. And then, therefore, must be at one point where R equals W, which would mean that the resultant force equals 0, and there's no acceleration, which means two things. It means he's not going to get any faster, he's at his terminal speed or terminal velocity, and also that because he's at his terminal velocity, this will no longer increase, which means his speed literally will not change. The amount of resistive force is not changing, and the amount and obviously his weight is not changing, so he will continue to move at the same speed. This is where we get into definitions. Free fall is when an object has constant acceleration of 9.81 meters per second squared, or just the local gravitational field strength. So for some weird reason, they may say, oh, actually, this is happening on Mars. So it might not be 9.81, it might be the local gravitational field strength of Mars. Whatever that is, go fact check that for me. I'm not doing it now. But that's what free fall is. Just ignoring any air resistance or any resistive forces, just a constant acceleration due to gravity, right? But considering air resistance, this is where we get the case of terminal speed, and we must be able to graph this as well. And what it looks like, and I'm not going to derive this with you, just going to go over to the next page because I kind of botched that graph. Um, what it should look like, again, we've got velocity time. So we already had the minus 9.81 just G here. Just going to label that one G. Yeah, sorry about that. So yeah, so it should start at 9.81 really because there's no resistive forces acting to begin with. You know, as we said, velocity equals 0, therefore air resistance equals 0. But the weight is unchanged. So we're going to start off with a line which is the exact same. I'm just going to make sure that's a little bit bolder there. But because the resistive forces increase as velocity increases, the acceleration or the slope must decrease. Or the magnitude of the slope should decrease, sorry. So we're going to get something like this. And then when it levels out, it's not going to rise back up. Because as we've said, it will no longer increase when it's no longer accelerating. Because resistive forces are directly proportional to the velocity that you're traveling at. So we're just going to get something like this. And if I just extend this out so that we can line it up, there will be that. Oh, that's not a very good straight line. That's a better straight line. That will be delta V. You don't, that's not like a part of the spec. I'm just saying there will be a difference in velocity due to this air resistance in comparison to um, the acceleration due to gravity under freefall. And that is really all there is to do with terminal speed. There's that graph that you have to know about, also starting at 9.81 and curving off and leveling off. Um, there's free body diagrams which you can use to help yourself. They won't necessarily ask you to draw any. And yeah, so resistance is directly proportional to velocity. When the resistance equals the weight, it will no longer accelerate. And when air resistance acts, it's obviously not going to get to such a high speed. Another side note, if you do further maths, this is probably more up your alley, but it also applies to just regular physicists. This is because if you think about energy methods, uh, you'll have a gravitational potential energy when you jump off that plane to skydive. But instead of all of that getting converted to kinetic energy as you travel, it will get converted as work against air resistance. So you'll sort of cap out a certain amount of kinetic energy, um, and thus a maximum terminal speed. So thank you very much for watching. I hope this has helped you understand the concept of terminal speed and why it occurs. And I'll see you all in the next one.